Here's a classwork problem that's talking about uniform distribution. So suppose that the reaction time in minutes of a certain chemical process follows a uniform distribution with that reaction time ranging between 10 and 20 minutes. We want to draw the density curve and then find the probability of a reaction time between 12 and 14 minutes, and then find the probability for a reaction time more than 16 minutes. The first step in finding this problem is to draw the density curve. Remember that in a uniform distribution, our density curve looks like a rectangle. This rectangle is going to have an edge to the left at 10 minutes and an edge to the right at 20 minutes. I'm going to let you pause the video and take a little time to see if you can work out this problem, drawing the density curve first, calculating the height of your new density curve rectangle, and then finding the probability of the next two questions. So pause the video, see if you can answer the question, and then let's check and see if we got it right. So hopefully you have drawn a density curve similar to the one that I have here. Remember, we're looking at a chemical process that is a uniform distribution, and the smallest chemical processing, the smallest time in minutes the chemical process is all the way down to 10 up to 20 minutes. So I have a rectangle here with a left edge of 10, a right edge of 20, and the distance from 10 to 20 is going to be 20 minus 10, which is equal to 10. So the height of my rectangle is now 1 over this base distance. So the second question here, part B, asks to find the probability that the reaction time is between 12 and 14 minutes. You can see my probability statement here in blue. Capital P, the probability that my reaction time X is between 12 and 14 minutes. So when I come to my density curve we drew, I'm going to draw a new rectangle, which I have color-coded in blue here. My minimum reaction time is 12, my maximum reaction time is 14. So I have a new rectangle drawn within the red rectangle, and the base of this new blue rectangle is 2, because 14 minus 12 is 2. So when I multiply the base of 2 times the height of 1/10, I end up with 0.2. And then pause the video and we'll look at the next one. So for this next one, the probability that a reaction time is more than 16 minutes, here's my probability statement written in green over here, and I've drawn a new green rectangle so that you can identify it here in the original density curve. So my value of 16 is the left edge of the rectangle, and the right edge of this rectangle stops at 20. So the width of this new rectangle, 20 minus 16, is equal to 4. So I'm going to multiply the width, or the base of 4, times that height, which still has not changed, of 1/10, and I end up with a probability of 0.4. So when you're doing uniform distribution probabilities, you first want to draw the original distribution curve, which is your rectangle and its original boundaries, in this case 10 and 20. Figure out what your height is going to be, and then begin to answer the probability questions.